So Pearson correlation coefficient, that to discuss to discuss the concept of covariances, we at the end of that lecture we have faced such problems, because covariance concept, if we change if we change the means if we change the scale of the data set, if we change the scaling of the data set, then the covariance is changed. Okay, so to avoid this problem, we have have the concept of the Pearson correlations coefficient. So let's see these things, how these things are work actually. So in short, the Pearson correlations coefficients, in short, these things are written in PCC. Okay, so the mathematical formula of these Pearson coefficients is, it's denoted by sigma of x and y. Sigma of the random variable x and y means this mathematical formula is simple covariance, that we have already learned how these things are actually calculated. Now after calculated this value, we have to divide this thing by sigma x. Sigma means standard deviations of the random variable x and standard deviations of the random variable y. And in previous lectures already we have seen how to find the random variable, how to find the mean of the random variable, and it's how to find the mean of the random variable x and y. Similarly, in same way, we have easily calculated the standard deviations of its. Okay, because we have some observed value of each random variable. By using simple this observed value, we can easily calculate these standard deviations and covariances. Okay, now let's see how this sigma xy means Pearson correlations coefficients are avoid this problem. Let's see this thing. So means this sigma x means simple, it's the root over of the variances of x. Okay, these things. So already we have seen that if x increases and y increases, then our covariance of x and y is what? Is positive. If it's positive, if x increases and y decreases, that means covariance of x and y is negative. We have seen this thing already in details. Now let's see how these things are actually work. Means, and if you just visualize the sigma of x means simply we have divided the sigma x and sigma y. Means what? So sigma x means what? Means standard deviations. Standard deviation, how much our data set are deviated. Is the sample, that's the measure, that measure the thing in standard deviations, how much data are actually deviated. And covariances, if you just simply divided the covariances on this standard deviations, if you simple divided the standard deviations on covariances, then this sigma xy we will got the value of the sigma xy. So because we divided the standard deviations, so this value will be lie on maximum value will be 1 and the minimum value will be 1 and its minimum value will be -1. Sigma xy, its maximum value is 1 and its minimum value is -1. This is the thing. But our covariance of xy will lie on the plus infinity to minus infinity. It will be minus infinity to plus infinity. This value. But after dividing these things, we will reach there. Now let's see geometrically. So if you just, I am taking this picture from Wikipedia, just search it on Pearson correlations coefficient on Wikipedia, you will got this answer. So if you just see these things, if our data point are properly linear, means if we just these things means what? This thing, if you just draw this thing here, this is simple. If you just zoom this picture, I think it will be better for us. Sorry, if you just zoom this picture, if you just zoom this one, okay. So for this picture, this is the x random variable, and this is the y, and this orange point, this is the scatter point of the 3 orange point. If you just see this thing, the orange points are the lie on a proper line. If you just draw a relations on these two data points, on these two random variables, it's properly lie on a linear line, okay, means it is purely linear data sets. Because of that, here it is the purely linear, and it's if x increases, y decreases. If x increases, y decreases. Because of that, its value is -1. Its value is means Pearson coefficient value. Simple and simple. This one row, this value is -1. But here is also x. This one is purely linear. I think I have done linearly. Sorry. So the spelling of the L-I-N-E-A-R. Linear. These are the purely linear. But here, if you just see this data set, these random variables, here x is increases, but y is decreases. These are the true. But it is the non-linear. It is not a linear data. It is the non-linear. So if these relations hold and it's a non-linear data, then you will see this type of relations from here. It's lie on the 0 to -1. It's sorry, -1 to 0. -1 to 0. In this range, the Pearson correlations coefficients are lie. Okay, in this range. Because actually we are dividing it through the standard deviations. Here standard deviation is what? Here actually if you just find the standard deviations and the mean, here actually standard deviations is, I think here the standard deviation that we got here, if you just divided this thing, then you will reach in proper -1. But here it's not true. Okay, because if you just if you have time, please I suggest you please come on the Wikipedia page, then they have the details formula they have elaborated. But I am going to understand the geometrical point of view, how these things are actually work as well. Here if you just compare these things, here it's x, the same thing, y, here x increases. It's the non-linear data first that you observed here. It's the non-linear means it's not lying on a line. That's in that sense I am speaking here non-linear. Okay, because it's the lie on a proper line. But here the data sets are not lie on a proper line. Okay, because of that I am calling about it's non-linear. Okay, so if here also you have seen that here x increases, but y is also increases, but non-linear. So because of that, these Pearson correlations value are lie on this range 0 to 1. Okay, but here but on covariance relations only we got it positive, then these relations hold. If negative, these relations hold. From the covariance concept, we cannot properly say that it is properly lie on a linear or it is something linear. Okay, we cannot got such kind of, but from the Pearson correlations coefficient we will easily decide that it is a properly linear or not. If our row value is properly 1 or -1, then we can conclude that it is linear, properly linear. But if it is not, then we cannot conclude it is linear but not properly linear. Okay, I think you got the concept here as well. These things are, but here if you just see these pictures, here there have no any relations on it. Suppose let's say it's a random data, there have no relations, no relation on this data. So because of that, they have no relations. So the covariance on this data is obviously 0. So because of that, its value is 0. Okay, because of this thing, the Pearson correlations value is 0. Now let's see some examples that I have also taken from the Wikipedia. Suppose let's take this first example, this one. So in that example, just if you see this data set, if you just see this data set, these are x and these are y. If this one happen, then these data set are linearly lying on a linear line, lying on a linear, properly lying on a line. This is a linear data set and also lie on a line. Because of that, this row value is equals to proper one, because here x increases as well as y increases, here is x increases as well as y increases, because that. But here if you just see this picture, just see this picture here x increases, but also y is also increases, but not lying on a line. These things are not lying on a line, means this kind of ellipsoid, these things are kind of ellipse. So because of that, its Pearson row value is, means Pearson correlations coefficient value is 0.8, means it's not proper one. And means from this point actually we got some idea how much data are actually spread, how much structures of our data. But only from covariance correlations, means only from the covariance we don't get such kind of concept. But here if our data are properly linear, then we will find that a properly linear, then it will find that is either it will be 1 or either it will be -1. But if not proper 1, then we got some idea. If it's just see this picture, from here is also, if x increases then y is increases, but here the spread for this data are more larger, means here here the sigma value, here the means standard deviations value are more larger, increased, here in simple. If standard deviation, just if you got the concept from here, if standard deviations are increased, then that implies the Pearson correlation row value has decreased, because we got the idea or we got the formula from here. Means just see these things, row are approximate. If you just taken the constant from some time, for if you taken the covariance is constant, means its relations is 1 by sigma. Okay, if it's decreased, if our standard deviation is increased, then row will be decreased. Okay, that's because of that things are happen actually. Now let's see these things. Now let's see this picture. Here actually it is taken the random data, there have no find any relations. So the Pearson correlations coefficients as well as the covariance coefficients both are the 0. Here the covariance and sigma both are the 0 or here from this kind of picture. Just say this thing, if you just see this thing from this picture, here x as it increases, y has decreases, because of that its value is negative. If it's more linear, then its value increased, and it is the linear, properly linear, and it tends to its properly -1. Okay, but here you just see this thing, means the simple thing is that if you just take this thing, here x is increases and y is increases, and it's lying on a linear. If the data points are lying on a line, if it is lying on a line, then we got the proper one. Okay, if it is x increases, if this relationship hold, then we got 1. If this relationship hold, means x increases as y decreases, then we got this value. Okay, just conclude this thing. I think it will be better for if you just write these conclusions. So it will be easy for us if you just write these conclusions. I think it will be better for us. So the conclusions that we got from here, If you write the conclusion, the first conclusions that we got, if x increases and y increases, the first thing that we have to observe, and if it is lie on a line, lie on a line, the second thing that we have observed here, first thing that we have observed, if x increases and y increases, second thing that we have mind that if lying on a line, then the value of the Pearson coefficients will be properly 1. Second thing, if x increases and y but y decreases, x increases but y decreases, that thing, and if it's lie on a line, first thing this one, and the second thing is if it lie on a line, then this value, sigma value will be -1. This is the first, this is the second. Okay, this means these conditions. Just say this thing. Just see this picture. Okay, now the third thing is that if this happen, if x increases, y increases, but it's not lie on a line, but it's not lie on a line, then what happen? Then this value means this value, rho value means rho value will be lie on this range, in this range, not lie on a line. It's 0 less than rho less than 1 on this line. If this happen, if this thing happen, but not lie on a line, then the value will be lie on -1 to 0. Means this thing on that situation, these things are happening. These things, and sorry, on these things -1 to 1, and first thing is 1. I think you have got the concept. Means these 4 type of situations. Means the such simple thing is that if our Pearson correlations coefficients are linear, our data sets are look like linear type of data sets, then that's come into the pictures. And the main advantage is that from the value of these Pearson correlations coefficients, we got some idea how much linear our data sets is. That's the main thing. How much linear. If it is proper linear, then we get the value either +1 or -1. If it is not proper linear, then we will got this type of value between 0 to 1. Okay. So now the second thing that is here. So everything is okay, sir, but if just see the structures of our data, this type of structure, if you just see this type of structures means this type of, so if you just see, if you just ask a 5-year kids what kind of patterns it should be, so the 5-year kids easily takes this one will be this kind of pattern that follow this curve. But by using this kind of pattern, this will curve, the curve, the data sets that have taken, means the data sets that have taken the patterns is actually look like this. So y is actually look like sine of x type of data, sine value, sine type of curve it has taken, plus some error, but some error have occurred here. Okay, just easily anyone can conclude that this is a sine kind of curve that data are followed. But from this kind of correlations, means covariance, means Pearson correlations coefficient, this cannot conclude how much safe it is. That's similar type of here. Actually it is a square type of data. This is also here square type of, just if you see this thing, this another kind of means this type of curve, it was this type of curve. If it is the x-axis, it is the y-axis, then these relations are actually look like this type. Y is equals to x square plus some error has, it will be. So that's the another thing, the error. But this type of pattern, this curve, this data actually follows. So but from these relations we cannot conclude. So easily you can see the Pearson correlations value from here will got that 0 value. Okay, we cannot reach some conclusion. We will see this kind of thing in the next, like in the when we grow further. So we will see how to find this kind of pattern to our data sets. We'll see these things. But now the disadvantage, now the drawback of the Pearson correlations coefficient, that we have to remove, that we will remove in next lectures, like that. So if our data sets suppose look like this type of pattern, so this is the drawback. Actually these are the drawbacks of the Pearson correlations coefficient that we removed in the next lectures. So the thing that I have removed by this one, the thing is called that Spearman correlations. Using simple the Spearman correlations, we will remove this drawback. So now let's see what is the actual drawback. So if you just look on that curve, these curves are actually monotonically increasing. Just see these portions of the curve. Just I am dividing this whole the data in such kind of. Suppose let's take this is the first portions, second portion. I have divided the whole area in 3 portions. Okay, 3 portions. This is the first portions, this is the second portions, this is the third portions of our data. If you see the second portions of our data, here in the second portions I am taking a different color. Just I am taking here the blue color. Just see the blue ink first. Here x is increased, but value, see the value of y. So if x is increased but y value are not so much increased, y is like on somewhere here, not so, means here in such cases, in this region x1, if x1 is increased but y1 not increased so much, is approximately equals to y2. That's the thing. That's we have seen in second region. Now come to the third and first region. Okay, in third region, if you just see this thing, third regions or first regions, here x is increased, as well as in these regions, first regions, x is increased, but see the y range, here y is also increased, here is also increased. Means what? Means in first and third region, that we got the concept that x1 here, if x1 is greater than x2, that implies that here y1 is also greater than y2, and these things are called the regions. If you see the regions 1 and 3, in these regions the curve are actually strictly monotonically increasing. This curve called the strictly monotonically increasing the curve. But here in the region 2, say these regions, in region 2, it's not monotonically increasing. So if you combine all the area 1, 2 and 3, if you combine all the area, if you consider all the area, in general these things in the both things are called the monotonically not decreasing. It is not strictly decreasing as well as it's not increasing. So these things are called the monotonically not increasing. Monotonically not increasing. That is the thing that called in this picture. Means this curve is the monotonically non increasing, non decreasing. Okay, means sorry, I am writing something. Means monotonically not decreasing. That means if you combine these both the cases, monotonically not decreasing curve means this curve is the monotonically non decreasing curve. It's not monotonically strictly increasing or monotonically not increasing. Means it's monotonically not decreasing. I think you got the, don't be confused, simple here. Just say these three regions separately. Means in first and third regions it's monotonically strictly increasing, but in second region it's not increasing. It's not increasing. It's constant value at appear here. So in such type of situations, this curve of sample called the monotonically not decreasing curve. Okay. And that's the another thing. So that the main problem for the main problem for the Pearson correlations coefficients appear here, occur here. Just zoom this picture. So just see this. If you just see this, the Spearman correlations coefficients are the value for the Pearson's correlations criteria we have got here is 1, simple 1. Means we will just before of that we will got, if we got the +1, then we can easily conclude that it's lying on a linear, it's lying on a line. But see the data set. These data sets are not lying on a line. These data sets are not lying on a line. Okay, but the value that we have got to calculate the Spearman correlations coefficient value that we got is 1. So this is the main drawback for our, but Pearson correlations coefficients means Pearson correlations, so the value got that 1, but Pearson correlations coefficients are give the value 0.88. Okay, so the Pearson correlations coefficient 0.88 means it's not lie on a linear line. Okay, so this value are decided that 0.8 not lie on a line. It's not lie on a line. That value we have easily concluded. First, you have to calculate the Pearson correlations coefficient value. Then by seeing this value, we can conclude that these things are not lying on a line. But by simple using the Spearman correlations value 1, we can conclude that it's a like of a non-monotonic decreasing curve. That's things we would say that the problem that I have faced here in Pearson correlations coefficients means if our data are look like this, if it is not a linear but it's monotonically increasing or monotonically decreasing, okay, to look like that type of data, then the Spearman correlations means they are the Pearson correlations are failed to give the answers. But in such scenario, the Spearman correlations are come into the picture to give the more appropriate answers. So that's thing, the Spearman correlations coefficients. The Spearman correlations coefficients. We will see this thing. We will discuss this thing in details in a next lecture. I think from these lectures we got the main idea how the Pearson correlations coefficients are work actually, and what is the advantage of this Pearson correlations coefficients from the simple covariance coefficient. Okay, the sample, if I conclude these lectures, if I conclude the idea that we have got from the lecture is like, if the sample, if x and y are both are increased, and if it's lie on a proper straight line, then we got the value is Pearson covariance value is +1. If x increased and y decreased, if x increased and y decreased, and it's lying on a purple line, then its value will be -1, either its value on this value. In this sense, means these four kind of situations we have got. But by simple showing the value of the Pearson coefficients, we can conclude its linearity, how much linear it is. This is the simple thing, how much linear. If it is proper linear, then we got the value +1 or -1. It is not a proper linear, then we got the value between +1 and -1. But we will see in next chapter that the Spearman correlations coefficients, that's come into the picture, how much non-linear is. If it is monotonically increasing or decreasing, then how much monotonically increasing and decreasing, and how much non-linearity occur here. We will see these things in the Spearman correlations lectures. Okay, that thing we will see in the next lecture. I think from these lectures we got some the idea of how the Pearson's correlations coefficients are useful to get some clarifications of the linearity of our data. Okay, I think you will got the idea in detail.